We done chi-square test or not? What is meant by chi-square test? We perform the test to check whether the accidents are uniformly distributed. Uniformly uniformly distributed or not. We check this chi-square test. All we have a feature selection. In feature selection, feature selection technique. How many techniques we have? Filter method, wrapper method, and embedded method, isn't it? So here we understood like RFE feature. RFE means what? Recursive feature elimination. Recursive feature eliminations. Okay. We also done that, guys. Regularization technique. So regularization technique are, we have L1, L2, and elastic net guys. So I think the spell, please adjust elastic net. Pretty clear, guys? Guys, don't talk. Both of you, Vishnu and Ritvik, just calm down. So regularization L1, L2, and elastic net. Are you guys done? Okay. So the next one, L1, we reduce coefficient to 0 or not, guys? To 0. But L2, what we done? We reduce coefficient not up to 0, but we can reduce. And also, what is elastic net, guys? It is combination of L1 plus L2. L1 plus L2. This part we finished it. And also we done practical. And also we done practical concepts we covered, guys. We are covered this. I hope understand. These things we completed. And next, today's session. Okay. Minimize and go to September. L1, L2, 17th. Next, today we build, sorry, yesterday. Elastic is not required, guys. So in machine learning, we go for L1, L2. Those two is enough. Elastic net is not required. We haven't implement anywhere in our algorithm. In future algorithms which you have, we never implement elastic net. So the things is done. So guys, regression is two type or not? Linear and non-linear. Linear part we finished. Linear part we completed. Next we go ahead to non-linear regressions. Everybody bought your laptop? Okay, what is linear, non-linear? So if I am x to the power 1, it's a linear or not? If I change x square, can I get straight line? No. This is non-linear or not? When I change mxq, we got non-linear. When we change mx4, so this non-linear. So in the non-linear, we do have some set of algorithms called polynomial, SVR, KNN, decision tree regressor, random forest regressor, XGBoost regressor, and we complete all those things one by one, guys. Okay, we complete them one by one. So let's start and understand polynomial regressions. In the polynomial regressions, let's understand and then we. So if you refer to the three equation, guys, 1 second. So here, see. In this polynomial, we increase the degrees of independent variable. Offline team, please listen. I don't know what you do in your laptop now, but focus on the class. The first thing is individual, we have increased the degree. I mean to say 0 degree poly, 1 degree poly, 2 degree poly. See this, guys. In this graph, if I fit this line, this is my best fit line or not? Because all the data points are nearest to the predictions line. And now in this graph, can I say, is this best fit line, guys? Why we can't say no? Why we can't say no? Because only two data points are interact with this. Only two data points are interact with this. So that's why we haven't called this is a best fit line. Pretty clear. Now do one thing. So here the value is 1. Simple linear, multiple linear. In polynomial, what we do, we keep change degrees 2, 2, 2, and then 3, 3, 3. Guys, you getting my point? So in polynomial means we keep change degrees of the independent variable. What is meant by poly? Many. For individual independent variable, we change the degrees, guys. For example, if you refer to this one, what happened, guys? Many form. No. Simple linear regression equation, y equal to mx plus c. Multiple linear equation, m1x1, m2x2, mnxn. Multiple linear regression. Polynomial regression, c, m1x1, m2x1 square, m3, coefficient 3, q, 4, 5. This variable's degrees are keep increase is called polynomial. Guys, are you understand or not? In here, in polynomial, what happened? X1 variable, we keep increase the degrees. Team understand? So this is the polynomial. I mean to say, let's introduce a practical, then we understand this one. So if I have this type of data points, I need to fit my curve like this, then only this is my best model. If I plot the best fit line, I don't get all the actual points are predicted to predicted point, guys. So in this graph, the equation is b1x1 b2x1 square. If I don't apply square function, I don't get my best model. Are you understand or not? Offline team and online team. I mean to say, if I remove this, guys, if I remove this, am I get a best fit curve? No, I'll get this fit line. So here only one point connected to the actual and predicted. So the moment when I add the square function, the curve is non-linear, guys. Isn't it? The curve is non-linear. Plus, I can add B3 x1q. I'll get another non-linear. So isn't it this curve is non-linear regressions? In linear regressions, from sklearn.regressions linear model, import simple linear regressions model, L1, L2. Are we done yesterday's practical, guys? Now today, I want everyone again open the laptop and we build this polynomial regressions, guys. And we build the workshop on polynomial model. So in the polynomial model, see, I want to introduce one project, and in the projects, let's see, I want to show you a data sets here. In this data set, every organizations, we has a hierarchy. Okay, what is the hierarchy? First, junior software engineer, next, senior software engineer, next, team lead, next, manager, next, senior manager, then regional manager, AVP, VP, CTO, CEO. These are the structures or not? Maybe some of the company has different structures. Maybe you can say data engineer, senior data engineer, or junior data ML engineer, or AI. So this is a basic hierarchy for any organization. So if any employee belongs to this level, the salary of an employee is 45,000. If anybody belongs to senior software engineer, the level is 2 because they grade system, 1 grade, 2 grade. We have grading systems or not? And if anyone from team lead, then they have 3 level and the salary is 60,000. Guys, I hope understand. So same way, CEO level is how much? What is the level? 10 and the salary is 1 lakh. So we have some of the data sets right now. So we try to apply in this data set, we'll apply two model linear model and poly model, two model we implement today, and we will see how the data fits, and we finish this algorithms, guys, and we complete this polynomial algorithm, and then we'll go for next one. So online team, shall we start? Online team, shall we start? Okay, yes. Just go here, and I want everyone, let me copy, and I will share this data sets to you. Okay, just click this one, download, upload, I'm sorry. So here, desktop. Okay, just go here and add to this one. Okay, online team and offline team, please download, and team, download the data set and work on poly model, poly non-reg model. Just post. And then all apps, Spider. Let's go to Spider. Straightforward. And we read the data set here. In this data set, check this. So this is the data set. See here. Just now we discuss all those things, guys. Position, label, salaries. Position, label, and salary. I mean, positions of an employee, label of an employee, and salary of an employee. Understand? We have three information. But now the question is, do you remember in school days, our teachers, they called us roll number or not? Roll number one, yes, ma'am. Roll number two, present, sir. We have these things. I mean to say, I don't find a position label. Can we remove position? Because level one, if it is referred to junior software engineer, we can count with label, guys. In government industry, if anyone working in electricity department, the pay scale will increase based on the grading system. Understand? Which grade the jobs are, grade 1, grade 2, grade 3, something like that. So the second one, I want everyone to just copy a new file and just go ahead and let me restart my kernel and just control V. So the first thing we done, just refer to this. Wait, restart the kernel. Just restart the kernel. 1 second. Okay. First thing, everyone read the data frame? Yes. Okay. What is the next step? Next step is we split the data into independent and can you tell me which is dependent, which is independent? Salary is dependent, salary is dependent. So these two are independent variable. But my question, I don't consider position because when I understand my level, so position is not required. So that's why in this data set, what I'm going to do, I'm going to split the data set into X and Y. X referring for independent variable and Y referred for dependent variable. If you go to the X, what exactly? This is label of an organization's employee. This is the label of an organization employee, guys. And then what happened? This would be the salary of an employee. This would be the salary of an employee. Guys, are you done? Because look at this. ILOC means index location. I mean, you know, slicing, x part 1 slice 2. That means 2 would be 2 minus 1, isn't it? 2 would be 2 minus 1. From the data set, how many indexes we have? 3 index, 0, 1, 2. I'm using 1 slice 2, means 0 never comes up here. I'm trying to print only x label column and y equal to dependent variable. Is clear up to this? Online team done? Okay, yes. Now, let's fit this model. Let me tell you, every time we try to do x train, x test, guys, x train, x test, y train, and y test. As the data set which I have now, very less records or not, only 10 record, because the organization standard is 10, guys. You cannot change the organization standards. The organization standard is 10 standard. Means what is, first one is junior engineer, second one is senior engineer. So what we do, so all the model, for all the model we will build, can we build the model without split? The answer is yes. Understand, guys? The next one, every till yesterday we split the model or not? Let's do one practical without split the x train, x test, y train, y test. So how do I fit it? Very simple. Are we build a linear regression model or not? Let's copy and I'll apply simple linear regressions model. And here I define a variable linear regression and fit x comma y. Guys, are you understood? Here I haven't done any scaling part and I haven't done any x train x test and y train y test because we have a very less data. Because we have a very less data. So let's go ahead and fit it. Let's go and fit it, guys. Understand up to this? Now you can type lin underscore reg, just enter. Do you see we build linear regressions, guys, here? You check the variable explorer, linear regressions model we built. Completed or not? This part we done. Now what we do, I want to, let's see, let's copy and I will share this, guys. The first one, I mean true or false. Okay, position level and salary. X-axis is position, and if I want to show this, okay, what happened? Just go to plots, mute one more time. Do you see this, guys? Now let's copy image and paint. My question to you, is this good model? Yes or no? Is this good model? No. Can you please check? Are you get this graph? Type this. So first, which model I built? Which model I built? Linear regressions model I built, and I see the model, linear regressions model I built, because SQL, and I see out of these many data points, only one point is predicted properly. Rest of the data point is not predicted properly. So is it finalized? No. So in these situations, in real time, 99% of the data set are non-linear. So that's why we must focus more on non-linear models. What is non-linear models? Polynomial, SVR, KNN, this all comes under non-linear regressions model. Okay. Now, are you got this graph? Just go to the code. Are you got this graph? Let me know yes or no. Not yet. I'll show this. Yeah, please type this. See here, plt dot scatter x, y, color red. Okay, color red color. This is actual. And plot linear regressions predict x and color blue. I need to line the predictions line. For the prediction line, which method I apply? Predict method. If you see predict, if you check this code and you keep your cursor and check this out, read these help options, predict using linear model. Guys, are you able to see that? And then you can say position level, title. So title true or false, or maybe I just remove the title linear regressions graph. I just change and save this. Control S, save the file. Okay, Control S, save the file. So it is a good model or not a good model? It is not a good model. That's why I need to go to the polynomial model. In this polynomial model, what happened? I need to increase the degrees of independent variable. I need to increase the degrees of independent variable. Everybody finished up to this? Everyone finished up to this, guys? Yes. Okay. Please complete. Everything done by sklearn framework. sklearn is machine learning framework. We use these frameworks and we done our task. We use this framework and we complete our task. Why guys? So please work this one. Just 5 lines of. Okay. Done. Very good. Out of 10 data points, it's only 1 or 2 predicted correctly. Rest of them high residual. High residual means what? High error. Predictions line and actual point is very far. So bad fit. You cannot say it's a best fit. We cannot say it's a yeah, bad fit. Now, that's why I introduce non-linear. To go for a non-linear, now try to understand this one. Polynomial feature. Let me go ahead and the first code I'll try to do one by one. So go back and let's do this. From sklearn.preprocessing import polynomial feature. Which one I need to implement, guys? By default, polynomial feature. Write this. And once you write this line, go keep your cursors over this import module and read this blog, what they're explaining, and let me know. Are you execute? Just go ahead and execute. Once I done, do you see my code is executed here or not? My code is executed here. Now, in this polynomial feature, if you see, this is all inbuilt parameter or not? This is called inbuilt parameters. In this inbuilt parameters, what was by default degree it mentioned, guys? By default degree was, in this linear regressions model, what was by default degree? What is by default degree? So 1 means linear, 2 means non-linear or not? 2 means non-linear. If you see, generate a polynomial and interaction feature. I told you this sklearn understand mathematics. Internally, a new feature matrix consists of all polynomial input sample dimensions because by default it considered a 2-degree poly in the parameters. Now, do you see each and every math equation internally integrated with this module. So you no need to write a separate math for this module. Guys, are you clear? So that's why sklearn is considered one of the very important libraries, guys. I hope understand what I'm speaking. So now just go to variable explorer, and once you're done polynomial, just go here, copy, and I'll remove. Can we create a object? Now linear regression is the object which hold linear algorithm, isn't it? Now let's create another object, polynomial regression, object for polynomial regression algorithms. Just go ahead and apply, and I create a new variable, polynomial regression. I need to fit and transform to my independent variable or not, guys? Just go ahead and fit and transform to independent variable. Can you please tell me what is by default degrees here? What is by default degrees here? 2. That means 1 square 1, 2 square 4, 3 square 9, 4 square 16. Guys, you getting my point? Just go ahead and open X square. Do you see this, guys, or not? X poly. That means 2-degree poly we apply to my independent variable. If degree 0, that means every value is a constant or not? 1 to the power 0 is 1, 2 to the power 0 is 1, 3 to the power 0 is 1, and degree is 2. Now, rather than I fit this variable, I fit second variable. My graph will change now. Why? Guys, how many of them understand? Do you see the math here? Look at this, guys. Venu, I hope you understood, right? What about rest of them? Rupinder and Hina, all the team members? All square, because I didn't mention anything. That means what happened? Internally, it call 2-degree. The reason why, if you go to the help and if you refer to that, and it's saying the degree equals to 2. This line, are we clear or not? In linear regressions, we use degree 1. And in polynomial, how many degree we use? Second degree. Now, refer to that. Just go here and I apply. Polyreg.fit x poly and y. What is mean by that? 27th line. What is this code saying? This code is saying x poly with 2-degree, please fit to the y. Just the moment when you say, do you see polyreg contains polynomial features or not? Guys, I hope you understood. Now, just go ahead and apply this line of code. Can you please write this 3 line and let me know? Please let me know. Are you completed? Are you complete? Okay, please write and I'll wait for you. It's not dependent. We apply math square function to the independent variable. That's why we generate a new table. Okay? Yeah. Now, do you see here in 27th line code, x poly? X poly we have 0-degree, 1-degree, 2-degree or not? X poly fit y. Degree till, so yes, by default it is 2-degree, exactly. By default it is 2-degree. This is parameter tuning or hyperparameter tuning? This is parameter tuning or hyperparameter? Parameter tuning, because by default 2 is implement. Now I want to fit x poly y. In before code, we fit the linear regressions with x, guys. Now I want to compare linear regressions, polynomial regressions. So polynomial regressions I use with degree 2. let's create another linear regressions with fit x poly comma y. So I create another variable, guys. Here I fit my linear regressions with variable x. But now do I see I created x poly or not? I want to fit my linear regressions with x poly. Can you please done this, guys? 30 lines. Done. Okay, done. Very good. Guys, this part clear or not? Guys, are you understand this part? So that graph will represent very good approve. I hope understand. Exactly. Now I'll try to this. Just go here. Okay. Now let me copy and I'm trying to represent as polynomial graph. Okay. Just use this and I'll plot here. Let's copy image. Are you able to see the graph now? Are you able to see the graph? This is linear graph. This is non-linear graph. What is the degree? What is the degree? 2. Is it a best fit graph? Best fit curve? No. Still the model is not appropriate. Still the model is not appropriate. Guys, are you getting my point? Now I want you to check this line. I want you to still better than, very good Animesh. Yeah, I can say still better than linear. Okay, now can you please write this now? Can you please write this code? Can we increase the degree? Can everyone change the degree 3 and build it? Degree equals to 3. And so when I change the degree 3 in X poly, can I create another column or not? 3. 1Q1, 2Q8, 3Q6. I mean 3Q how much? 27, 4Q64. In degree 2, I fit this as independent variable, salary as dependent variable. Correct? In degree 3, I will fit this as independent variable. You guys understand or not understand, team? Yeah. Would you changed, Pupinder? Now go here and yes, best fit. Yes. Now just go ahead and I want to execute all the code at once. See the graph, copy maze and paste. Guys, amazing or not? Do you see this actual and predicted both are equal? Okay, I want to explain. Just go to this one. Please write. Completed this code, guys? Completed this code? Are you got the graph? Okay, understand or not understand? Yes. Almost we can say like best fit line. We won't get best fit line because that is not a line, that is a curve. Okay, I'll introduce sigmoid function, sigmoid curve. We have all those things later. Okay. Now, so please show how the graph looks like. The graph looks like this one. If we go to here, this one, this graph. If I compare this graph, which is better, degree 2 or degree 3? Degree 3 is better. Degree 3 is far better because actual predictions both are matched. Are you completed offline team, everyone? How many of them done? All of them? Okay, you got this third done. Still, can you change degree 4 and let me know? Okay, Swaraj, degree 4 is the best. You checked it? Now I'll move on to the degree 4. Machine learning codes are easy, not so tough. First time when we do, little understanding here and there. After that, you will play around it. Just go ahead and execute Now let's go back. Guys, do you see this is a fantastic model or not now? So actual and predicted both are equal now. Just go here and mention if you see this actual predicted both are equal. Guys, are you understand up to this? But before you do this, I want to open xpoly. Can you open this variable? Do you see the math formula? Independent, this is independent variable 100 constant. This is degree to 2, 1 square 1, 2 square 4, 3 square 9, degree 3, 2q 8. So what exactly trying to explain here, guys? When I apply linear regressions model, the model is fit with this is as independent variable, dependent variable as salary. Understand? The moment when we apply polynomial feature, the model convert the degree to 2, and rather than fit this, we fit the model with second degree poly and we fit with salary part. When we change hyperparameter tuning, what is parameter tuning? Degree 2. What is hyperparameter tuning? Degree 3. The model automatic calculate the Q function of each and every independent variable, and this considered as independent variable and fit to the salary. The graphs are more accurate. The moment when I change the degree to 4, and do you see we got actual equals to predicted. You no need to worry when to use which model, time will tell. Just allow me 2 weeks, things would be understood. I'll give more practicals as well, you can work. I hope this concept's clear or not clear. I hope this, so in parameter tuning, we can have 2 degree, but in hyperparameter tuning, we can have degree 4. What if I change to 5 degree and then go here? See, I mean to say actual predicted both are equal means we don't for the next step. We stop this model here. We stop this model here. Always remember model accuracy will increase in hyper parameter tuning only. Understand? My question, if I don't do hyperparameter tune, can we consider this is a best model? Let's say by default degree 2, guys, right? Can we consider this as a best model? Yes or no? No. No, we cannot consider it as a best model. So remember, in ML model, we called as parameter and hyper. In hyperparameter, we called as ML and deep learning. In large language model, we called as fine tune. In large language model, this concept we called as fine tune. We have a concept of fine tune the RAG model. Fine tuning the RAG. Guys, you understand? See, the technical jargons are very important. And I'm writing each and everything to make you understand. So parameters which given by system. Now, in large language model, Llama 3 has trained with, initially it was 2 billion parameter, guys. In this polynomial feature, how many model? How many parameters? 1, 2, 3, 4. So this polynomial regression algorithms trained with 4 parameters. That's why I can able to run in my CPU. LLM models trained with 400 billion parameters. Can you run on your local machine? That's why that is called large language model. How many of them understand? How many of them understand, guys? Are we clear? What's meant by large language model? So, see, every algorithms had some. So this is tunable. I can do anything I want it with this algo. But in these LLM models, so that's why Llama 3 has introduced all the model. First, the GPT-3. It has trained with some billion parameters. And now GPT 3.5, it has trained with another extra parameters. We keep add the parameters. So that's why these models we cannot handle. And every company, they won't set up the infrastructures to handle this much of data. So the data is growing. When the data is growing, we don't have a machinery items to take care of them, guys. So that's why many organizations developed a new softwares, new website. Same way, there is a website called Grok. You know what is Grok? So Grok is an American company which they develop a large language model. It's trained with very huge data, guys. So that's why they quantized the model. They quantized what is meant by quantization. Quantizations means they quantize a large model to system runnable models and execute in your Google Colab file. If you understand, it should be great. If you not understand, no problem. I'll explain later. So I'll introduce the new technique called quantization. Okay. So this is all those things we have. So Hugging Face, I introduced to Hugging Face later. So at this moment, as we're working on polynomial, I want to connect how this machine learning jargons has connected to LLM models, generative AI. Guys, are we clear? In machine learning, we developer feed the data. Do you see we feed the data? Which data? This data sets I load or not? I load means what? I feed the data to the machine. In AI, we feed text data. We feed images. We feed videos. We load videos. The videos may be 2 MB, 2 GB, 4 GB. But large in generative AI, we cannot load any data. The data load by internet itself using API keys. So I hope you guys has a little understand about ML versus AI versus Gen AI. Are we clear, guys? In ML, a user or developer load a data set, and the data set is number. In AI, a user or developer load images, video, speech, text, all those things. But again, we have some limited data. But in Gen AI, there's no questions of user. Forget about user. The data trained from internet, website, XML file, research paper, PDF, and that's why we'll use using API keys. So this Gen AI has created by multiple organizations we discuss later. So today, if anyone asks what is difference of ML AI, Gen AI, I hope you guys very crystal way you can explain to interviewers as well. Online team, how many of them clear? What exactly things going on? Team, parameter tuning, hyperparameter tuning, fine tuning. Fine tuning words we'll use later when the time comes up. Okay. Now, guys, I hope in this practical we use parameter, hyperparameter. Now, I want to create another use case. The use case is, for example, this is the independent variable. Assume, so we have some certain level or not? So some certain level in the sense, one second, let me close data set. If, see this, let's say AVP is about to quit the job. AVP is about to quit the job. When AVP quit the job, so new AVP will replace or not? A new AVP will replace. Now, what is meant by automation? Every company do automation or not? What is meant by automation? Quantum computing. Quantum is a different. Quantum computing, IBM quantum computing, it's still in research phase. Quantum computing means the heavy machineries they want to integrate with these computing systems, guys. As the see, this is what researchers are working on, more practicals on cloud, and they wanted to do a big up things, guys. So everyone has to be learn cloud as well. If the one in any platforms you work, there's a few things you have to understand: data science model, LLM models, and when you integrate, when you add more technical skills to your learning stacks, you will grow. You know, guys, when you learning to our learning stacks, we should grow. Now let's have a look at this. If now I want to predict, let's say a new employee want to join in your company. A new employee wants to join in your company. And let's see, your model will predict and his experience is 7.5. So what could be the HR will give a salary, guys? It should between this range or not? Guys, are you getting my point? It should be between this range. If I say for 6.5, so what could be the range? The range would be 1,75,000. The average point, if 7.5, it should be 2 lakh. How much, guys? Maybe we can go for 6.5. Now let's have a look at this and we try to close it. Now try for that. I want to add this one. Just refer the 2 lines of code and now I'll add this now. Let's see if a new employee want to join in the existing in your organization which have level, his experience is 6.5. So what could be the predicted salary you expected? 6 is regional manager level, 1,50,000. 7 is 200. It should be the average between or not? It should be between. Maybe 1,75,000 or 1,70,000, something like that. 18, yeah, it could be anything. 18, 19, based on it. But let's see, we build linear regressions or not, guys? Let's see my linear regressions model predict how much? 3,30,000. Is it accurate prediction? What is the CEO salary itself? The CTO salary, the VP salary is 3 lakhs. Now your linear regressions model predicts 3,30,000. Absolutely wrong or not? Absolutely. So that means why wrong? Because we got wrong. The reason being, look at this graph. The reason being is no data point fit to my predicted point. That's the reason we got the wrong predictions. Are you agree with me? Now, if I go to the polyreg fit, what is how many degrees now? Degree 5. If I go to the degree 5 and if I check this, what is my model predicted? 174. Accurate or not? So now in the same code, just refer linear regressions model with the degree 1, it predict the 6.5 level salary is 3,30,000. 3,30,000 the company will pay you. Do you think company will pay? No. Polynomial, poly model, with how many degree? Degree 5, the model predicts for 6.5, 174 point, just go here, 878. Guys, getting my point? Now, if I change the degree to 4, just go to the 4 and let's rerun again and check what is the model predicts, guys. Let's see, poly model predict 158, 862. Just copy and degree 4. How much I got now? 150,862. 158,862. Guys, you see the changes? And then if we change to 3, just go ahead and refer one more time and 133,259. Do you see this, guys? Let me copy and predict 3 and 133,259. So let me tell you guys, 133,259 means it is less than 150 or not? See, what is 6 salary? 150. If my company say, if your salary is 1 lakh, and if your salary is 1 lakh 50 and you join a new company, if the company will pay 1 lakh 33, will you join? No, that means this is incorrect report. This is incorrect predictions, guys. This is also if your package is 1 lakh 50 and if you go to another company, if the company will pay 158, would you join? No, you bargaining or not? Please increase more salary. But here the HR will come back. So we'll finalize this salary. And now it depends on you, whether you join or not. Guys, I hope you understood. So can you please tell me how do I fix my model? With which parameters? Which parameters I fix my model? Degree equals to 5. This is what my backend code. This is what my backend code. Now, can we create a front-end code? You can try that. If not, I'll get back to you tomorrow. So how many of them understand today? I have, we can build several model on top of it. And we comparison of all the model, then we find the best fit model, guys. Then we find the best fit model. So this data set, we build polynomial model. What is my model accuracy, guys? 174, 878, correct? Tomorrow, in the same data set, I will build SVR model and I will see the comparison or not. Then I will build KNN regressions model. I will compare. Then I will build decision tree model. The data set is same. Let me tell you, the data set is one data set, so we can build multi-model and random forest R model, and whatever gives you best accuracy, that we can go for deployment. That we can go for deployment. So always understand, whenever you build any machine learning model in one data set, you cannot build one model and leave. You can try to pass multiple model, implement in one data set, and we check the accuracy and then we go for it. For example, in Hyderabad, there is 10 restaurant. Okay, if I say which restaurant food is tasty, what you do? You have to visit all the restaurant and you finalized or not. So regressions model, we have many model, same data set, we apply all the model and we finalize the best accuracy. That we go for deployment and we do a future forecast. Are we clear, team? So right now the reason being I introduce less records to understand the concept, and then we'll give one project. I'll give you one project you can work. Clear, team? How many of them understand every lines of code? How many of them did I share to you? Thank you for each Easy explanations. Very good, Masood. One data set, you can implement all the machine learning. Many of the people do not understand machine learning. The reason being they directly jump to the machine learning. But if we don't know EDA correlation, can you show line 43? Okay. I can pass 7.5 as well. What if degree 6? So, okay, I mean to see, guys, why you apply degree 6 when actual equals to predicted? It doesn't make sense, right? The values will shuffle, the values will change, but doesn't make sense. Yes, Apurv. So how many of them completed? Offline team, everyone done? Okay, good. You understand? Now go home and work again. Create a front end if you have a time and deploy, mention in your GitHub. And how to use these models in upcoming SVR, we'll go and understand